So hi everyone. Today I'll be in this demo. I'll walk you through a RAG chatbot built using an agent-based architecture with structured message parsing. So let's start with the Streamlit UI. So the Streamlit interface loading. So here is the Streamlit interface. So here the user can uh, upload any multi-format documents like PDF, docs, or text, and ask a questions like what is the total revenue from the annual report, etc. So let's try it out with an example with a PDF that I downloaded from IRS about the last quarterly update uh, of the second quarter. So here let's ask the what are the total appropriated funds, which should return this 37,621 number, and it should also have a context that it is written in millions. So okay, let's go and ask that. Uh, so what is the what are the total appropriated funds? So let's submit this question. So the system parses the file and retrieves the most relevant content and uses the LLM to generate the context-aware response. So he below is the answer. As you can see, it returns 37,621.5 million, which is exactly the same number and with the context that it is in millions from the original PDF. So this way, and it also returns the chunks which have the supporting context from the query pipeline to ensure the traceability and also making the bots reasoning transparent. So now let's deep dive into the whole system and how it works. Uh, okay, now as for the architecture, this it has the mainly three agents, which are ingestion agent, retrieval agent, and response agent. The ingestion agent pre-process the document by parsing the document, and it also supports multiple formats using libraries like okay, we'll go through the code later. So and it also chunks it into semantically meaningful blocks, and the retrieval agent what it does is it generates the OpenAI embeddings for the chunks and performs a semantic search using FAISS vector database, and it also selects the top K chunks which are most relevant to the user query, and then there is the response LLM response agent which takes those chunks and crafts a prompt to send it to OpenAI's chat API to get a context-based answer. So the system flow is this is the simple system flow where the user interaction connects to the ingestion phase, and then to the retrieval phase, and then the response phase to the output phase. So okay, now uh, let's go through the code. So So all the messages between the agents were sent through this bus with a schema, with this particular schema, where the which where the what do you say, each agent uses a standardized message format which is inspired by model context protocol. Each of these messages include a sender, a receiver and type of the message and the trace ID, so it can be traced back to later, and the main payload. And this okay. Now all these messages are routed through a central bus, which delivers the messages to the correct agent by looking at the receiver field here. By looking at the receiver field, so that the agent's input will go to that particular receiver, and it won't be mixed up to the other agents. And now let's go through the code walkthrough. Let's at first we have the modular folder structure, which separates MCP, main bus, and utility utils and agents. And in the agents folder, we have each agent has its own Python file, which is coordinated using the co- coordinator agent file. And in the first ingestion agent, it handles the pay, it as I already mentioned, it handles the ingestion of the PDF, and then returning the MCP message to the retrieval agent. And now the retrieval agent receives that input, and then retrieves the closest ones from the closest embeddings, semantically similar embeddings from the FAISS vector store, and then builds a MCP message to the LLM response agent, in which the LLM takes that payload and the top chunks from the retrieval agent and builds a MCP message to the what do you say, coordinator agent, where the final answer will be uh, sent to the Streamlit front end. And then in bus, I already said this. So checks the receiver who receives using and invokes that particular agent. And then there are other in utils folder we have files like embedding.py, which handles the OpenAI embeddings, and now the LLM.py we have here, which makes what do you say, prepares the prompt with the context chunks and user query, and sends it to the LLMs and waits for the response. And okay, now this is the details. And the message retains it also has uh, with MCP that we schema, we'll have trace ID, so we can trace back to it, to this to ensure the continuity across questions, user queries. And this can be in this does not implement any chart history kind of thing, but this trace ID can be used to implement a memory kind of future upgrade, if we are thinking about it. So, and yeah, in we'll move to the Streamlit app. So this is the UI part, and then what do you say, the session state. Yeah, this is the Streamlit part, and we have yeah, now let's okay, now yeah, that's all about the project. And if we are going want to see the um, how it works in the total system flow diagram. Oh yeah, this one I already mentioned from the code itself, that center receiver part, and from the system for the system flow detailed system flow diagram we can see here, where the user uploads a document and enters the question from to the Streamlit UI, which forwards the documents and question to the coordinator agent, and where the coordinator assigns a unique ID to each of the query and creates a MCP message MC message which looks like something like this, and now this message is routed into with the trace ID and documents into the ingestion agent, where the ingestion agent parses the whichever the document is uploaded using format specific parsers, which it is already mentioned here. Yeah, depending on the type of the file, it will take care. And now splitting the text into chunks of size 500 and with an overlap of 50, and it attaches the metadata inside the ingestion agent itself. And now this ingestion agent sends these chunks to the which part is this? Yeah, the retrieval agent, which then generates the which embeds the chunks using OpenAI embeddings. The OpenAI embedding model which used in this one is, yeah, the text embedding 3 small model. And now these chunks which are not indexed are then stored in the FAISS vector store, and it also embeds the user query, and then semantic, it performs a semantic similarity search, and the closest to top k number of context chunks which are semantically similar to the query. Here the k for now is set to be 5, so it returns the top 5 semantically similar chunks to the, and sends it with the as a payload to as a context response with the MCP messaging protocol. So it returns the top chunks and the query to the LLM response agent. So this LLM response agent, what it does is, uh, it constructs the prompt with the context and user question, and then calls the OpenAI chat completion API, which is GPT 3.5 Turbo used here. And now it receives the answer from the GPT and sends the answer to the front end, the Streamlit UI. So now Streamlit, where the it what do you say? The Streamlit displays the final answer as we seen, and then it also shows the expand below the 5 uh, top k number of chunks that are yeah, sent from the retrieval agent to it. Okay, now, yeah, that concludes my presentation. Yeah, these are the chunks as I mentioned earlier. So yeah, now with that I would like to conclude my presentation, and the code is already in the GitHub, and I will finish it up. Add these rest of the files and the video and the PPT also to the GitHub, and we'll submit it. Yeah, thank you.